Hello, this is Ellie from the Math Center. Today we're going to be going over trig subs in integrals. The example that we're going to be examining today is the integral of 1 over x square root of the quantity 9 minus x squared. In order to start this problem, we have to do a trig sub. The way that we start a trig sub is by drawing a triangle. We populate the sides of the triangle with the components that are inside our integral. We put x on the base here because x is found inside of our integral. We also have the square root of 9 minus x squared on the other leg because there's a minus inside here, and by Pythagorean theorem we can find the hypotenuse, which is 3. From this triangle we're able to get the relationship that x equals cosine of theta. From this we get dx is equal to negative 3 cosine theta, the hypotenuse times the cosine of theta. Dx is equal to negative 3 sine theta d theta. We're also able to find this leg by using sine, the opposite over the hypotenuse. So we'll get the square root of 9 minus x squared is equal to 3 sine theta. Substituting all of these components into our integral, we get the integral of 1 over 3 cosine of theta times 3 sine theta times our substitution for dx, negative 3 sine theta d theta. Multiplying, crossing these two out is acceptable, as well as crossing one of the 3's out. So we get negative 1/3 times the integral of 1 over cosine theta d theta. This is equal to negative 1/3 times the integral of secant theta d theta. In order to approach this integral, we have to rewrite secant of theta in a very special way. We have to multiply it by a very special form of 1. In order to get a reasonable u substitution, we multiply it by secant theta plus tangent theta over secant theta plus tangent theta. It's important to note that this is just a very special form of 1. Secant theta plus tangent theta will be our u, and when we take the derivative of this, we get secant squared theta plus secant tangent. So if we were to, when we multiply this out, we get negative 1/3 times the integral of secant squared theta plus secant theta tangent theta divided by secant theta plus tangent theta, all d theta. So as I was mentioning before, we're able to do a u substitution here, where u is equal to the denominator here, which is secant theta plus tangent theta. Du is going to be the derivative of secant theta, which is secant theta tangent theta, plus the derivative of tangent theta, which is secant squared theta. Making this substitution, we get negative 1/3 the integral of du, of du divided by u. This would equal negative 1/3 times ln absolute value of u plus c. This is then equal to negative 1/3, making the substitution back into the ln of secant theta plus tangent theta plus c. Now, in order to get from the theta domain back to the x domain, how the problem was initially posed, we have to solve using the triangle that we used before for secant theta and tangent theta. Secant theta is equal to hypotenuse over the adjacent, so we get 3 over x, and tangent theta is equal to opposite over the adjacent, square root of 9 minus x squared over x. Substituting these values into our solution, we get negative 1/3 ln of 3 over x plus the square root of 9 minus x squared over x plus c. Combining these two together with their common denominator gives us 1/3 ln of 3 plus square root of 9 minus x squared over x plus c. And we have our final solution.